Hello and welcome. Today, we are diving headfirst into one of the biggest, most mind-bending questions in all of science. And that question is, does reality only exist when we're actually looking at it? Now, that might sound like something straight out of a movie, but trust me, it's a question that has physicists genuinely stumped. You've probably heard this old philosophical riddle, right? It's the perfect place to start because it really gets you thinking about the line between a physical event, the sound waves themselves, and our perception of it. It's our doorway into a reality that is much, much weirder than you can imagine. For the longest time, the physics answer was super simple. Of course it makes a sound. Duh. The world just happens, whether we're there to see it or not. But then, about a century ago, this little thing called quantum mechanics showed up and just flipped the entire table over, turning that simple, common-sense answer completely on its head. So, to really appreciate just how wild the new ideas are, we have to take a quick look at the old ones. For hundreds of years, our view of the universe was, well, pretty straightforward and predictable. Honestly, it was kind of comforting. This is the world Isaac Newton gave us. A world where if you know how fast a baseball is going and where it is, you can predict its exact path. It's a view where the universe is like a giant, intricate clockwork machine. Every gear, every piece has a definite place and a definite job, and it does that job whether we're watching or not. You close your eyes, the moon is still there. Makes sense, right? And here is where it all comes to a head. On one side, you've got that classical, clockwork reality that feels so intuitive. But on the other, you have the bizarre quantum reality that, it turns out, runs the whole show at the tiniest levels. We're literally going from a world that's solid and independent to one that's built on pure probability. And somehow, it all seems to hinge on the very act of looking. All right, let's dive into the quantum realm, where the rules of our everyday world don't just get bent, they shatter completely. This is where things get really interesting. Okay, so at the absolute heart of quantum mechanics is this concept called the wave function. I want you to picture an electron. Before you look at it, quantum mechanics says it's not in any one single spot. Nope. Instead, it exists as a cloud of possibilities. It's a little bit over here, a little bit over there, all at the exact same time. The wave function is basically the math that describes that ghostly cloud. And here it is. This is the central mystery. The moment you try to measure that electron to actually pinpoint where it is, that whole cloud of possibilities instantly vanishes, and the electron just snaps into one single definite location. It's almost like the universe is playing coy, refusing to make a decision until we force its hand by looking. This, my friends, is the infamous measurement problem. Which brings us right to the core of this whole thing. Is the electron always in one place, and we're just revealing where it was all along? Or is it truly smeared out in that cloud of possibilities, and our active looking somehow creates its reality by forcing it to pick a spot? Just sit with that for a second. The implications are absolutely staggering. Now, physicists have been fiercely debating this for 100 years, and they've cooked up a few potential explanations. You can think of them as the main suspects in our investigation of what or who is collapsing the wave function. There are three main players here. First up is the classic Copenhagen interpretation, which basically says, reality is fuzzy and undecided until we measure it. Then you've got the wild one, the many worlds idea. It says the wave function never collapses. Instead, every single possibility just splits off and plays out in its own parallel universe. And finally, there are objective collapse theories, which say this whole collapse thing is just a natural process that happens all by itself. No observer needed. Thank you very much. For the longest time, this whole debate was fixated on that word, observer. And a lot of very smart people, even some of the quantum pioneers, thought this meant you needed a conscious mind for reality to click into place. But here comes the biggest plot twist in our entire story. So get this. The crucial insight is that observation is kind of a misleading word. The observer doesn't have to be a person. It doesn't have to be conscious at all. A single particle of light bouncing off an electron counts. A stray air molecule bumping into something counts. Any little interaction that carries away information about the system acts like a measurement. This whole process has a name. It's called decoherence. So here's how it works. You've got your quantum system, our electron, chilling in its weird cloud of possibility state. But in the real world, it's basically impossible to keep it totally isolated. The instant it interacts with anything around it, information about its state leaks out. And that entanglement with the environment is what forces the system to drop the act and pick a state, making it look and behave just like our normal, everyday reality.
So, after all these twists and turns, where does our investigation land? Let's go ahead and deliver the verdict based on where most physicists stand today.
So, back to our tree. Does it make a sound if no one's there? The modern answer is a pretty confident yes. Reality doesn't seem to need us or any conscious mind to exist. But, and this is a really big but, the very properties of that reality, things like the definite position of an electron or the specific sound waves from that tree, they are defined through constant interaction with everything else around them. Reality isn't some static picture we look at. It's a dynamic, never-ending dance of interaction. And that leaves us with one final, kind of amazing thought. If interaction is what pulls our world out of a fog of quantum possibilities and into the sharp focus we experience every day, just think about the billions upon billions of interactions happening to you and around you right now. The light from your screen hitting your eyes, the air on your skin, the floor supporting your chair, every single one is a tiny part of a cosmic conversation that is constantly defining and redefining the universe. Thanks for joining us.